This is once again Jack here from Prosoft Technology Group, your host. We are going to have this wonderful webinar on reference architecture, and Ram Kanumuri is going to be the coach who is going to walk you through. Ram Kanumuri is the IT strategist and advisor for Prosoft Group. Ram, if you could just come to the second slide. Yeah, okay. Now I'll just take a minute in introducing a little bit about Prosoft. We are a global IT service provider established in 1995, and we are now a part of Kelton Tech, which is a public limited company. So we are, as of 2016, 1,000 plus associates, as headquartered in Ireland with offices in Chicago, New Jersey, California, and India. And the practice areas are into ERP and integration. So under ERP, it is STATT, and under integration, we cover ESB. We have expertise on API, SOA strategy, business process management, and high-risk cloud surrounding software AG, IBM, and Prosoft. Yeah, just be on mute, please, all the panelists. So these are the partial customers from Prosoft's end, right from retail, manufacturing, financial, energy, and other quick customers. And I request Ram, if you could just coach a little bit from here, from the next slide. And also to all the attendees, we are going to have a question and answer session at the end of this webinar. I'm sure we are going to have many questions where we would spend some quick 10-15 minutes to answer all those. But before I hand over it to Ram, this is a quick slide on the technology expertise and adoptions we have. Ram, on the about, if you could just go to the slide number, what was that? The before slide? Already, yeah. So we are integration partners with IBM and Complete Software AG, and we are in a process of partnering with MuleSoft and Informatica. Thanks, Ram. Over to you.
Oh, thanks, Jack. Thanks, everybody, for joining our webinar series. Just to continue on with Jack's introduction, the Connected Enterprise Services Division, this is our core portfolio of services. We definitely help our customers in IT portfolio management and providing enterprise architecture strategies, specifically in the middleware integration domains, including BPM and analytics. Our core strength has always been in application integration, whether it be B2B, A2A, and applying various architectural paradigms, including SOA and API-based strategies. BPM solutions and BPM-based solution development, either BPM as a architectural paradigm for business process improvement, or even for orchestration. Those are multiple technologies that we support as well. We also provide data integration, data governance, and master data management through many ETL tools and technologies that we support. We also provide real-time and streaming analytic solutions through, again, IBM and Software AG tools, which apply these analytics and streaming analytics on IoT-based business solutions and big data applications as well. We provide full and thorough services on SaaS integration, cloud enablement, and hybrid infrastructure services, moving your current infrastructure into cloud, whether it be AWS, Rackspace, or even IBM's Bluemix. Finally, we do provide extensive infrastructure modernization, infrastructure engineering, and also some aspects of continuous integration, or in some cases we call DevOps. All establishing such continuous integration architecture and deploying environments is our expertise as well. And of course, not the least, we also provide end-to-end AMS services. This slide just describes our adoption of various technology and tools that we support extensively. This is just a snapshot of one or many tools that we build expertise on and also establish what we call COE, investing into experts and labs and solutions that we continuously develop. So today's agenda for this webinar, I wanted to touch upon reference architecture, why and how reference architecture is important, and how can it be established, what are the various considerations on establishing a reference architecture. I'll also talk about what is contained within these reference architecture and what are the various architectural paradigms that reference architecture can be applied to. But before I go there, I wanted to talk a little bit about the evolution of integration platforms and the integration layer and domain itself. Essentially talking about, we have been very familiar with these integration platforms. Even from the beginning, we had B2B based environments, to establish communication with our trading partners or our supply chain or even our customer networks. But also we had architectural paradigms that are applied in application to application integration. It could be simple data synchronization patterns, or it could be services oriented patterns or messaging patterns. We have also seen integration platforms used extensively for business process modeling and orchestration. We have seen them used for task and case management, workflow, and human workflow management as well. We've seen integration platforms to be used for end-to-end monitoring and visibility of transactional data as it flows through the enterprise. We've been using integration platforms for, of course, application integration, but a lot of messaging and complex event processing of multiple data points within the enterprise. Also, the middleware platforms are extensively used for ETL, data management and governance as well. Of course, these are the concepts and these are the paradigms that we have been used to or have been able to leverage these patterns and technologies and extensively been successful in employing them. So we can call them, these are the proven enablers. But off lately, we have started to see a lot of trending disruptors. So a lot of disruption that we see, of course, a big buzzword nowadays is digital transformation, and anybody who's not talking about it or even having to put a roadmap around it is probably being left behind. But a lot of that digital transformation encompasses, adopting cloud, adopting SaaS, and deploying your middleware or even the rest of the infrastructure into a hybrid model, being able to analyze large data or streaming data from SMAC or online transaction processing or IoT-based applications, being able to change our application development paradigms to employ microservices strategy and API-based strategy, even moving APIs to the front end into HTML5 and mobile apps, but also employing governance on all of those paradigms are the trending disruptors. Of course, composite application frameworks and agile applications that will allow for these rich UI, UX on mobile and front end is the digitization of your enterprise as well. But more so, enterprise class containers and scalable in-memory engines, being able to create applications in microservices architecture and being able to componentize them in memory scalable platforms. Big data analytics and online transaction processing analytics are also some of the core capabilities that our customers are looking for these middleware platforms to provide for. So these are our trending disruptors. Now, of course, we have been familiar with what integration enterprise integration platforms does for us. Without an enterprise integration platform, many applications and your landscape would look like something like this when we used and point-to-point legacy integration. But over a period of time, enterprise service bus or middleware platforms were able to make sense of all the integration needs and provide a right platform to manage all the integration needs in a single platform, and that's what the enterprise service bus have been able to do for us. So as a result, the organizations have built out infrastructures over time and have typically ended up with a spaghetti diagram that looks something like in the previous slide. But most large enterprises have adopted what we call a enterprise class middleware or enterprise service bus that allowed for many normalization of integration needs across the enterprise applications. So what we have been doing in middleware platforms in the last 10 years is not only connectivity and transformation, being able to mediate and message and route, providing access control. These are some of the core functions that we have been employing with these middleware platforms. But trending recently and into the future, we should be aware of the trending core functions that we need to support, including APIs, Swagger and core support, OAuth and OData support, big memory in-memory usages, scalability, MQTT, IoT, cloud enablement. These are the newer capabilities that you have to be looking for in your middleware platforms for your digitization of your enterprise. So in that aspect, I would like to quickly touch upon what we think about a maturity model and a roadmap for enterprise integration. I think at the lowest level we see most of course not the large enterprises, but many smaller companies might not have an enterprise architecture in place or would not have adopted an enterprise integration platform. Most integration needs are point-to-point, maybe small FTP, end-of-day processes. So this probably is the level 0, and I suppose any large enterprise cannot sustain this level at all. But definitely, the second level is when we start using integration technology specific to, say, a particular capability that we are looking for, like being able to communicate with the partners or doing FTP, doing simple data synchronization across applications, maybe employing some real-time integration. But still, most of the integration solutions that are employed in this level of maturity, the enterprises are still attacking the requirements tactically rather than strategically. That's the major difference here, and that results in a lot of point-to-point. Of course, they will never be able to reuse and bring down the cost of this domain. At level 2, an enterprise would have adopted an enterprise class ESB, a large enterprise class platform from IBM, Software AG, TIBCO, MuleSoft. Many of these platforms provide extensive capabilities that meet your enterprise integration needs. So there will be minimal governance need, integration design needs, because a lot of the patterns and best practices are established through these platforms and vendors. So there's, of course, still we start employing a lot of solutions on the top of these platforms. We start to see growth in these integrations and the solutions that get deployed, but we don't really see any reuse. And also, at this level, if the enterprise sticks to this level and not mature, they will very soon see a proliferation of patterns, and eventually the platform becomes unsupportable, because unlike application platforms, middleware and integration platforms are unique in a sense that they always grow. Every year you put something into it and keep growing. So without what we call architecture and a consistent application of patterns, most middleware platforms will become unmanageable for change, for operations, for control. And that's why we always recommend that a ESB reference architecture is very, very important, more important in middleware platforms and integration platforms than application development. The reason, as I said earlier, is integration and middleware platforms grow in their landscape and capacity every year, and it is very important to build boundaries around our own certain architectures and patterns that we would establish. So here is where the level 3 we start seeing enterprises to adopt what we call a reference architecture in place. And then this reference architecture would bring in the reuse. Maybe we'll bring in a reduction in the total cost of ownership and also improve time to market. So all these are the objectives of reference architecture, and we'll slowly down the line see what it actually means, how we will do it, and things like that. At the highest levels, we've seen the reference architecture actually provide for their digital business transformation, and also provide for cloud reference architecture and many other aspects. And we have also seen many enterprises consider integration as the future killer app. Why we see that integration is going to be the killer app is the trending of many enterprises is to go to cloud in the form of SaaS or in the form of moving their core applications into the cloud. Also, the infrastructure has already been moved into cloud for many enterprises. Now it's the applications that are going to go into the cloud. Many enterprises are breaking up the large monolithic ERPs and throwing bits and pieces of functionality into the cloud. Being able to effectively integrate SaaS applications, multiples of these SaaS applications, and orchestrate their APIs and constitute in that orchestration the heart of your business processes. That's what the future is going to be, and most enterprises will see that very soon the center of gravity will go into cloud of their IT landscape. So that means more than 50% of their IT landscape will be SaaS. Now, being able to integrate and manage those SaaS applications and SaaS connections, and being able to do cloud-to-cloud integration, cloud-to-on-premise integration, hybrid integration, that is what is the needs of tomorrow. And when most of these SaaS applications that you can adopt in the market today are being API-based as well. So most SaaS applications create APIs for interfacing. And of course, these APIs are also being standardized with OAuth and OData. And integration, which then orchestrates these APIs with other SaaS applications or on-premise applications, will constitute your business logic, and that's why it's called the killer app. Now let's go into the reference architecture and what it is, and what it should do, or what it should contain, and what we would do when we say we establish a reference architecture. So simple form, reference architecture forms the strong foundation for adoption of a chosen architectural paradigm. That's the first and foremost. Then you can say, yeah, we will have an API strategy, we will have an SOA strategy or a BPM strategy, but what does it mean? What does it mean is we need to establish the architecture for those paradigms, and then be able to govern against that architecture in the SDLC and the operations of this domain. So integration problems can be solved in several different ways. It is important to solve them using established patterns or providing for better reuse, scalability, performance, and supportability. That's the most important goals of reference architecture. Reference architecture for middleware is just like a design for an application development. So what should ESB reference architecture do? It should lay down a strategy and a roadmap. It should create architecture and design guidelines. It should lay down governance procedures and policies. That's the most important step. So it's not only establishing the architecture and guidelines, but being able to govern those guidelines and architecture during the SDLC, during the operations, during the change control, and things like that. Many aspects of reference architecture will cover the deployment architecture. I'll go a little bit detailed later, but deployment architecture talks about various components that are part of the middleware. For example, a processing server, a messaging server, a portal, a B2B gateways, security gateways. All these are different components that constitute a middleware, and how to deploy them, how best to deploy them. Is your deployment architecture scalable? Is your deployment architecture federated? Will it cater to different business silos? All those are aspects of deployment architecture. Software architecture talks about the actual coding and development of these integration patterns, whether it be interfacing, whether it be transformation, whether it be messaging. All those patterns are established in this software architecture. Software architecture document for ESB is the Bible in this reference architecture arsenal. It is the one which will guide subsequent down the stream implementations and projects to choose the right patterns from this architecture and adopt them into the scope of that individual project. The reason we want implementation phase projects to adopt established or documented patterns is that to, again, the same point, to keep the number of patterns that we proliferate in our middleware to a minimum and a manageable number. Usually, we want to establish such patterns up front and evolve them and mature them as we go forward. So definitely the deployment architecture document and the software architecture document are not set in stone in the beginning. They are evolving documents as well. So as I said, the reference architecture document is typically a high-level document that provides an overview of the ESB domain in the aspects of design, build, and run. Usually this document is for analysts and business users and PMO who have not carved out the requirements yet to a level that, yes, we know what integration requirements are, what application requirements are, and what the end-to-end requirements are. This guideline document is the one which will allow the analysts and the architects to introspect what can be done in the middleware and integration layer, and that thereby being able to carve out the original business requirements into integration requirements. The deployment architecture document I was talking to you, it contains the physical and logical architecture of various ESB software components, and it will describe processing, messaging, orchestration, gateways, etc., and their high availability, scalability, and federation models that they can support. Software architecture will definitely talk about integration patterns and design patterns, but it actually is the guardrails of all software design in the ESB. Other artifacts of reference architecture could include ESB strategy and an implementation roadmap, also the requirements and capabilities guideline. Also, definitely depending on the choice of our architectural paradigm, whether we are SOA shop or API shop or a BPM shop, they would create those guides as well. In case of API, there could be a microservices architecture guideline and governance policies, life cycles policies for development life cycle, policy enforcement policies, registry repository, asset governance. All these are aspects of governance of SOA and API that we'll be bringing in as well. Some other aspects of some other artifacts that we can create during reference architecture exercises, definitely the development handbooks, naming conventions and best practices handbooks, common frameworks handbooks. A lot of the middleware platforms employ, over a period of time, repeatable common frameworks like logging framework, error handling framework, monitoring framework, and things like that. And all those frameworks are reused over and over in multiple projects and multiple implementations. So it is very important to document such frameworks so that they can be definitely reused more and more, bringing down your cost of ownership. Of course, in cases of API and SOA, you would have specific handbooks that we would create for schema design, WSDOs, and Swagger best practices or course best practices in API. All those are documents that can be produced as part of the reference architecture document. Now, knowing that what we need to do or what we need to create in an ESB reference architecture, but the next step is to how do we do that? I mean, how do we create a deployment architecture? How do we create a ESB reference architecture? We do that with our COE. We have to establish a center of excellence, an integration center of excellence that will constitute, your IT sponsors, the enterprise architects, of course, definitely the integration architects and the data architects, but definitely the business process architects and system architects of all the other application domains also need to participate in producing this reference architecture. Now, maybe these are the actors that produce these architecture artifacts. The process that we need is what I'll discuss about next. We have been successful in establishing a 5-step process in establishing, say, this reference architecture. In many organizations, we would want to start with redefining the requirements of the middleware, of the ESB. Usually this happens because we want to make sure whatever patterns that are already implemented or established are meeting the requirements that are seen for the domain in the first place. So when we say redefine the requirements of a middleware platform or integration platform, we would go back to interviewing all the application domains. Maybe we have a large ERP, we have a large landscape of legacy systems, and we have another domain which is rich in the front-end UI, UX. We would look at all these domains, interview those domains, their roadmap and strategy, and capture all the requirements that we foresee. We can say, for example, all the legacy systems have in their roadmap to modernize their applications, convert their Kix application to service-enabled or API-enabled. So that's a requirement. That's a really good requirement. So that actually translates into the second step is, once we have defined all the requirements, how would those requirements be met with the existing platforms? So we go deep into our existing technology that we have already adopted and all the technology that we own, and perform a gap analysis on what are the capabilities of these technologies, whether they will fulfill the requirements that we have identified above. That's the second step. The third step is we go in and assess all the IT assets, any frameworks, any designs, any implementations or solutions that are currently implemented. We would assess them against the architecture and best practices and standards. We would also assess the skills of the people that are within the teams at our customers. We would also look at the organizational strategy and procedures, and the governance aspect of it in the organizations as well. Now, the 1, 2, and 3, the outputs or the discovery from 1, 2, and 3 steps would be used to evaluate and provide recommendations in step 4. Step 4 evaluation can also involve what we call product or technology evaluation. So it can include to evaluate multiple technology platforms that can cater to you and your needs. We can do a thorough PUG analysis and derive right recommendations for the evaluation of this technology. Once we are done with 1, 2, 3, and 4, now we have the requirements, a clear set of requirements for the domain. We have identified our gaps, both in technology and people and process. And we have also laid out an evaluation of the technology and provided a roadmap and recommendations by step 4. By step 4, end of step 4, we have a clear idea now on what is our architectural paradigm that we're going to apply. Maybe it would be API strategy, maybe it would be BPM strategy. Whatever is the paradigm, next step that we need to establish is the reference architecture for that paradigm, and that's the step 5. Define the implementation strategy, define the reference architecture, software architecture, deployment architecture, and any other reusable frameworks. So again, going back to the 5 steps, the requirements, we want to make sure we capture all the techno-functional requirements of the domain as it looks into, when we said we interview all the application domains and their perspective and roadmap and their integration needs. So it typically, for any enterprise, we touch upon their customer view, their IT view, their business view, define various scenarios, and then transform them into requirements for each scenario. We have matured this process. We have templates that bring in a lot of requirements that we can deliberate and then articulate for each customer into his own requirements. Once we perform the gap analysis, gap analysis report and documentation on reusable components from existing ESB implementation will also be done. And we provide for an assessment report. Usually the assessment, as I said, not only covers the technology tool set, but definitely the skill set of people and the training needs of our people in the ESB domain. But definitely, assessing the enterprise vision, roadmap, funding, and architectural direction in the implementation of ESB is what we have included into that assessment, what we would do. We would also, as I said, evaluate production tools, including a thorough analysis. We call PUG analysis of technology across multiple product evaluation and provide summary reports for that as well. As I said, in the definition and implementation strategy phase, we define the ESB reference architecture, deployment architecture, logical component and software architecture, define the mediation patterns, provide governance guide, and eventually lay out an implementation roadmap for the modernization of this platform. Now, some of the considerations during establishing this detailed reference architecture, I would like to talk about. A lot of our customers and a lot of organizations now are talking about API and API strategy. In some cases, you can call it microservices and reference architecture. So what does it mean is typically establishing an enterprise API strategy. When we talk about APIs, for many customers, it could mean many things. Of course, first and foremost is the APIs that the enterprise itself would develop and produce, right? I mean, if you have an application development environment, an application development that is a continuous development and continuous change, maybe like a DevOps kind of an application development environment. Now, we have traditionally been doing monolithic applications, or the microservices architecture redefines that paradigm completely. So the microservice architecture in application development is one of the core areas of reference architecture we would do. But also API just not mean API development for those applications that we have in our development lifecycle. But APIs would mean dealing with third-party APIs. As I said earlier, most enterprises are adopting SaaS applications left and right. I mean, I think very soon many enterprises will see that their SaaS application adoption is hitting the roof. So connecting with these SaaS applications, we have seen Salesforce, which is a big player, but you'll be surprised a lot of shared services or enterprise services divisions use a lot more, like Kronos, Workday, Payday. Even in small SaaS applications, sometimes our organizations might adopt a SaaS applications that we don't even know about, just because we didn't have the need for integration yet. But I can guarantee you that down the line, as enterprises become more and more digital, they will need a very strategic architecture in being able to integrate all these SaaS applications, and not only integrate with them and integrate those SaaS applications with, say, our core applications or on-premise applications, but being able to also connect these SaaS applications in the cloud to cloud as well. So various patterns on how we would establish communication between SaaS applications, SaaS to on-premise, on-premise to SaaS. What are the various patterns? Will there be a system of record services? Will there be end-of-day bulk load services? All those are patterns that we need to establish in third-party API consumption. But also, some of the APIs that we create internally need to be exposed out. If we are creating applications and application APIs that we want to monetize, maybe provide access to our partners and customers, we need API gateways. We need ability to secure those APIs and being able to support OAuth and OData. Those are the traditional challenges that we will see in an API strategy and in a microservices reference architecture strategy. So the reference architecture would definitely address all these areas in being able to articulate the necessary best practices. Same thing in BPMS and BRMS based reference architecture. We have a well-defined, mature process in being able to analyze a particular enterprise for its BPM and process readiness, something like process discovery, and then eventually implementation and adoption and development of those BPM-based paradigms. Reference architecture supports a lot of these aspects as well. When it comes to core application integration or the core integration technology, being able to define our patterns, synchronous request pattern, asynchronous request patterns, publish subscribe patterns, mediation and virtualization patterns, data aggregation patterns are some of those core concepts that we have to elaborate in our software architecture as part of the reference architecture definition. Also, canonical and entity modeling is also most important, whether it be API or SOA or integrations and interfaces and messaging. Anything that goes through the integration layer is data, and there has to be a heavy focus on being able to standardize on the data model itself, whether it be WSDL as part of SOA or whether it be Swagger as part of API or JSON as part of messaging. A lot of the data definitions or data models have to be standardized as well. Being able to standardize and document some standard definition models, data models, will help in being able to establish common patterns as well. So data modeling is the front and central of reference architecture responsibilities. Of course, establishing the best practices in ESB is the first and foremost importance for the reference architecture. Being able to document all the common frameworks, being able to document and address proven designs for error handling, logging, and notification. All these are aspects of reference architecture that need to be documented and released. With this, I think I would like to open up for questions and question and answer session. I think we have 10 minutes for question and answer sessions. Meanwhile, I will leave this slide open. We have a few more upcoming webinars. Of course, this webinar is the reference architecture webinar. We have another one coming up next week, specific to Software AG web methods customers, how to use Command Central in centralized management. Not only the provisioning of infrastructure, but how to leverage Command Central in many other ways. It's an exciting topic that you can hear from Subramaniam Chavali. Of course, modernizing the web methods ESB and an upgrade, those are another topic that Sudhir Kante will take up. Yogesh in August has an exciting demo of Internet of Things. He would talk about messaging, MQTT messages through what we call Bluetooth, low Bluetooth emitting receivers. So we were able to create a use case which we call in retail industry back to store strategy, on how we can apply back to store strategy use cases using iPhone Bluetooth BLE technology. Our parent company had created what we call a KL game that will be demonstrated in that presentation with Yogesh. At this time, Jack, I would like to take up any questions that you can see from the audience.
Thanks, Ram. In fact, yes, I already have a couple questions for you, so I really wanted to go ahead right away asking you those. So the very first one I see here for you, Ram, is can we create a list of criteria to assess the maturity or obsolescence of reference architecture?
So criteria for reference architecture, whether it's working or not, that's what I think I meant by the question. In most cases, again, as I said, we have to create a reference architecture for the architectural paradigm that we have chosen. So it depends on each customer and how and what it means for them, what middleware means for them, or integration layer means for them. Some customers might have a problem to solve with say B2B communication. Maybe they have large partners that need to integrate with, thousands of partners. So their problem is purely B2B. So depending on what the problem is, whether it's B2B or API or BPM, the reference architecture will address the particular paradigm in particular. And what it needs to do is it will establish all the norms, best practices, guidelines, and to know whether it's working or not is something that we cannot say or calculate in a few as soon as it's produced. Definitely we want to make sure that our objectives of reference architecture of an architectural paradigm is to bring down the cost. Eventually that's the first and foremost objective, being able to bring down the time to market of some of these solutions. So if your reference architecture is not helping you in being able to reuse some of the solutions that you have created, if your reference architecture is not helping you to cut down the time to develop or time to market, then we obviously it is not meeting its goals, right? We want to bring in reuse. We want to bring in best practices and common implementations, and we want to bring down the cost of integration over a period of time. Those are the criteria that you would look and measure to say whether your reference architecture is working or not.
All right. Okay. So here goes the second one. How are ESBs primarily used in today's companies? Do microservices take away from some patterns that were primarily deployed in the ESB in the past?
So that's a very good question. A lot of times, the API strategy or the API mantra nowadays, and some people, actually even some analysts would say the ideal API strategy is which will eliminate the ESB altogether, right? Now, that might sound right for Amazon, where all their applications are developed in home and everything talks to each other in APIs. It might work, but not all enterprises are Amazon or not all enterprises are being born digital like Airbnb and Ubers. Of course, Airbnb and Ubers, they have a different API strategy. They don't have legacy systems. They don't have existing landscapes, and they pretty much are 100% SaaS if they have any applications outside of their own. would eventually be all SaaS, right? So in that scenario, the API strategy is a little different. You know, they would definitely concentrate on microservices strategy. They would definitely concentrate on building their applications in that modular fashion, and they might not realize the need for a full-fledged enterprise ESB. But in most enterprises, we are talking about an enterprise which is transforming their strategy, say from those legacy applications 15 years ago to these ERPs, 5-10 years ago, and now into cloud and SaaS applications, into the future. So API strategies for these enterprises mean not just the APIs or microservices that will be used in building homegrown applications, but we have to deal with APIs that are part of SaaS applications. So Salesforce adoption will result in consuming Salesforce API, and we know SaaS applications and their APIs change every year. Sometimes they might release even every half year. So every time your SaaS API changes, your connections or your implementations need to be agile enough or flexible enough to cater to that change. So essentially establishing an architecture that will allow for consuming third-party APIs, being able to create our own enterprise application development APIs, and being able to expose our enterprise APIs for monetizing through gateways. All that becomes the API strategy, and of course you cannot expose your APIs over the internet into security gateways and establish security and authentication without a middleware platform, right? Of course, you can ask an application to do it itself, do all that by itself. Then you would be asking all the applications that need to expose APIs to do things on their own. And again, sometimes I feel that yes, ESB is still relevant. Integration is still relevant, even in the future SaaS-based world, and actually not only relevant, integration will now become kind of an application. Actually, you will start seeing, as you start integrating more and more SaaS applications, as you start creating processes that will orchestrate various SaaS applications, where will that orchestration reside? I mean, either you create a separate application that can composite your SaaS applications, or you would use your middleware, maybe create a BPM, maybe create a composite application which consumes all these APIs from the SaaS applications and create a picture for your business process. So that is where middleware is trending. Definitely API does not eliminate the need for an ESB. I hope that answers the question.
Right. Okay. Thanks, Ram. So other one for you. Should we compromise architectural integrity to align better with the organization, or should we adapt the organization to serve the desired architecture?
That's a tricky question, but definitely there has to be both aligned, I would say. Whatever architecture that we adopt, especially say BPM, sometimes BPM can be used not only for system level orchestration, but actually business process level analysis. Now, even say, for example, business IT demand management. Now, if you're putting BPM in a place where it will cater to a particular architecture, then in that case, the organization governance or the organizational model, like how your departments are aligned, how your departments or a particular asset or a software component that being developed, how does it get articulated in various departments? Who's the one who will approve the design? Who's the one who will do the testing? Who's the one who will approve deployment and operation? All these are people, and if your architecture and if your governance model does not match with your organizational model, then there's a conflict. Your architecture and your governance will not work with your organization. Either you have to change your organizational structure to meet your governance model, or you change your governance model to meet your architecture, organizational structure. But I think from the question, what I understand is, yes, they need to be aligned and they need to be in sync. Usually, the organization models are solid. Most organizations that can't really change or go into a reorg until it is warranted. So most software architectural patterns or software architecture paradigms and their governance should align with the existing organizational model and not the vice versa.
Hey Ram, to your previous question we had from a customer who was asking, do microservices take away from some patterns that were primarily deployed in the ESB? So you have given a response to that. So to that, the same customer wants to know, is the API manager then essentially part of your middleware or integration platform in the future?
It is. Definitely it is. When we say API manager, so there are multiple aspects. So first of all, if you are talking about APIs that are being developed in-house as part of application development. Now, as you can understand, microservices strategy is a little different architecture. We have been used to creating monolithic applications where we have for each application we might have a group of UI UX developers. They do their UI UX job, right? They're isolated and they do their own job. We have the application logic developers and J2E Java developers, and then probably Hibernate and data access developers, database side developers. But microservices strategy actually is a different approach, right? It brings that one UX developer, one business logic developer, and one database developer. They put them all together into one team, and they create one module of the application as a microservice. So that approach is organizationally also very different from what we have been using. Now, what is API management is, assuming that's the approach that we're going to go for, we definitely know that these APIs that many teams, many sub-teams now within the same application have to create needs to follow standards, right? So they need to know whether we were going to go for RESTful services or JSON services or what kind of definitions we would have, whether it's Swagger-based exchange or RESTful based exchange. All those are aspects that we have to define. Now, API management will then talk about the governance of itself of the API production. So when we say a life cycle of an API being created, it has to be conceived, it has to be designed, it has to be reviewed for design, and then developed, then also deployed in runtime for consumers to be using it. So there's always a producing side, producers of the API, and the consumers of the API, being able to bring them to a portal so that the consumers and the producers can collaborate is the aspect of API management. So the aspect of governance, the aspect of registry and repository, the aspect of being able to discover these APIs from the consumer point of view, being able to produce these APIs in a managed life cycle surrounded with governance is the aspects of API management. But also once the APIs are created, they need to be provisioned, Node.js or any other containers. Now, provisioning of those APIs, the applications themselves can provision these APIs to be consumed by the consumers. But a lot of times we have seen middleware plays a role there as well. Middleware now will actually create what we call entity level APIs or enterprise level APIs or a mature API. What the ESB would do is ESB would consume these application level APIs and compose them into a mature API, a process level API, and things like that. So that's where APIs, ESBs play a role, not only consuming the application level APIs, but also being able to consume.
Ram, you there? We lost you. Alrighty, I think there is some technical issue, but that was the last question I have to take. With this, I thank you all the participants who really made some time in making this webinar a success. I'm going to send a thank you note to all, and all the attendees who are interested with any specific inquiries you have, or if interested in having this presentation, I can of course send it in PDF. So just let me know. You can reach me at jack@prosoftgroup.com, or at the same time, anyways, I'm going to send you an email. You can get back to me on that. With this, I thank you all, and you all make a great week and a great day. Thank you.